Okay, so I have a couple examples for you. You probably will want to have out your notes from the last video that we did that has those formulas on them because we're going to use them. I'll refer to them. So this is from your textbook. I don't have the page number written down here, but in chapter 16, number 34, about pets. So I'm doing two examples. The American Veterinary Association claims that the annual cost of medical care for dogs averages $100 with a standard deviation of $30, and for cats averages $120 with a standard deviation of $35. So the first thing I want to do is come up with some symbols to represent both of all those numbers. We're talking about expected or the expected cost of or the average. So we're going to use the mean symbol. So I'm going to say mu sub d, and that represents the mean for the dogs, is $100. And then sigma sub d is $30. And similarly, I'm going to say mu sub c for the cats is $120. And sigma sub c is $35. Now, when you use letters like D and C to represent dogs and cats, you don't have to define the variable and say, let mu sub D be the average cost for dogs. It's understood that you're talking about dogs and cats. However, and sometimes in your textbook examples, I'm not sure sometimes people use like an X and a Y. If you do that, you would have to actually define your variables. So you're better off, and I know you've heard me say this before, you're better off using letters or variables that represent what you're talking about, and then you don't have to worry about, did I remember to define them? So if you look at what we're being asked on part A, by the way, the reason why I'm using the symbols, remember that these are the population symbols we use because they're telling me in the problem that they're claiming that that's the annual cost of medical care for dogs and cats, as though it was the population, not talking about a sample. So in part A, we're asked, what's the expected difference in the cost of medical care for dogs and cats? So we're talking about dogs minus cats because we want to know the difference. Now, it doesn't say dogs minus cats, but I would read it in the direction since they listed dogs first. So then what I'm really looking for in part A is I want the mean, the expected difference. So I want the mean of dogs minus cats. So if you look back at our formulas, when we're talking about means and we're adding or subtracting, it would be this one. So we just can add or subtract just like that. So the means for random variables can be added or subtracted. So we would just say this is the mean of the dogs minus the mean of the cats. So we would get 100 minus 120. So that gives me negative $20. So we could say, on average, the annual veterinary costs for cats, I could say, is $20 more than dogs. Now, so that would be if I was, interpreting my answer. Now, if you had done mu sub c minus d, then you would have ended up with a positive 20, and that's not wrong. And that's why it's really important that you use symbols to describe what you did, so that because it would be correct to do it that way as well. On part B, we're asked, what's the standard deviation of that difference? So we're being asked to find sigma of d minus c. So I'm going to look back at this, and you have to remember to combine variances. Well, standard deviations don't add, variances do. So we have to first deal with the variances of the problem. So we're going to find sigma square of d minus c. Let me go back to the formulas one more time. Remember also that even if this is subtraction, this is always add. Whenever you are combining two variables, you are always going to be increasing the variance, not because you're combining two variables, so they're more varied. So that's the reason why it's always going to be plus. So that's something that you would have to remember. So it's the same thing as sigma squared D plus sigma squared C. So then we're going to take, my standard deviation for dogs was 30. So we're taking 30 squared plus 35 squared. And I believe we have 2,125. Yes. And that is the variance. We want the standard deviation. So I'm going to take the square root of this answer. And I get, it's money, so I get $46.10. Okay, and that would be my standard deviation. So that's part B. Part C, by the way, let me make a comment about this. This is only true if costs for dogs and cats are independent. So you'd have to think about whether or not the veterinary costs for dogs and cats are independent. If these were dogs and cats that came out of the same home, we might not be able to consider those independent, because if a person didn't take proper care of their dogs, then maybe they don't take care of their cats either. So that could become an issue. Then on part C actually, it says if the difference in cost can be described by a normal model. So that's like a flashback, but that's going to be extremely important moving forward. We're going to be coming back and doing a lot of things with the normal model. And they ask, what's the probability that medical expenses are higher for someone's dog than for her cat? Okay, so what that means is we already know that our mean for the difference between dogs and cats is -20, and we know that our standard deviation for the difference of dogs and cats is 4610. Now they're telling us that these differences in cost can be described by a normal model. So remember, a normal model has two parameters, the mean and the standard deviation. Well, we're going to use these for our mean and our standard deviation. So I'm looking at a normal model with a mean of -20 and a standard deviation of 4610. So remember that when we are talking about a normal model, we're going to draw a picture. My mean is -20, so that's going here. I'm going to count out 3 standard deviations, should cover about the whole distribution. And I'm going to need some values here. So if I take -20 plus 4610, I get 2610 here, and I'll just do one the other way. -20 minus 4610, I get -6610. So I could set this up, but then I got to think about, what does it mean to say the probability that the medical expenses are higher for someone's dog? Well, that would indicate that I'm looking for the probability that if I look at the difference in costs, if the dogs are higher than the cats, then the difference would have to be greater than 0. So that's what I'm looking for. So then I'm going to find a spot on here about where 0 is, and I'm just going to mark a spot here and say 0. I mean, probably not the best. And I want to know greater than 0. So there's my picture to support my work. And then to solve this, again, kind of a flashback to earlier days here, we're going to go second distribution, normal CDF. Remember, we actually never use normal PDF in our class. My lower bound is going to be 0. I don't have an upper bound, so I'm going to do something ridiculously high. My mean is -20, and my standard deviation is, 4610, and I need an answer. And so I get as an answer, let me move this. .3322. So that's the probability that I'm looking for here, that someone's medical cost would be higher for their dog than their cat. All right, so number 36, also talking about pets. So you're thinking about getting 2 dogs and a cat. Assume that annual veterinary expenses are independent. So that's important for us to recognize, because that allows us to add and subtract variances, or add variances, I should say, and have a normal model with the means and standard deviations described in exercise 34. Define appropriate variables and express the total annual veterinary costs you may have. So I'm going to start with some of we know that the dogs are approximately normal with a mean of 100 and a standard deviation of 30. We know that the cats are approximately normal with a mean of $120 and a standard deviation of 35. We're looking at getting 2 dogs and 1 cat. So I'm going to use subscripts for D sub 1 and D sub 2. Actually, let's say this is plus, because we want the annual cost. So D sub 1 plus D sub 2 plus C to represent my 2 dogs and a cat. So if I want to, still in part A, so if I want to express this total, I'm looking at mu sub D1 plus D2 plus C. And I can apply the formula because the means add. So it's mu sub D1 plus mu sub D2 plus mu sub C. So then we just get 100 plus 100 plus 120. So my expected annual cost would be $320 if I had 2 dogs and a cat. Also still in part A, I have to address, I'm looking for the standard deviation. But remember, standard deviations don't add, variances do. So actually, I'm going to start by finding the variance. So when we do this, we're going to get sigma squared for the D1 plus sigma squared D2 plus sigma squared C. So then I end up with 30 squared, which is 900, plus another 30 squared, which is another 900, plus if you square the 35, you get 1225. So that total is 3,025. That's the combined variance, but I want the standard deviation. So I'm going to square root that. And when I do, I get about $55. So that would be my standard deviation for this setup. So part B says describe the model for this total cost. Okay, now when you're asked to describe a model, that's like looking for what kind of distribution is this going to be. Well, since the dogs and the cats both came from a normal model, then when we combine those, it's also going to be a normal model. So in part B, we will have a normal model, and our mean is going to be $320, and our standard deviation is going to be $55. So what we just did is going to tell us our mean and our standard deviation. So then we're going on to part C, which says, what's the probability that your total expenses will exceed $400? So in part C, I'm going to draw a picture. My mean is 320. I'm only going to go to the right since we're exceeding 400. So if I do 320 plus 55, I end up with 375. So I'm not quite to that 400 yet. So if I add 55 to that, I'm at 430. So I'm going to find approximately, I want the probability that my total expenses, so let's call that D1 plus D2 plus C is greater than 400. So I'm going to find a spot and call that 400. And I want it to be greater than that. So again, the picture and with everything marked, we are not doing z-scores. So this is your supporting work. So you definitely want to make sure that you include that. So then I'm going to do second distribution, normal CDF. My lower bound is 400. My upper bound, something ridiculously large. My mean is $320. My standard deviation was 55. So I get my probability is 0.0729. So that would be my probability of having the expected cost or the total expenses exceed $400. So you'd be, fairly confident that you would not be exceeding $400. So that gives you a couple of examples. Now I do want to just mention that and I don't think any of your problems are going to deal with this, but there's a difference between if the medical care can vary differently or vary the same. And so in this case, just because one dog gets sick doesn't mean the other dog does. So their medical care costs could vary separately. There are some situations where you are dealing with a variable that they have to vary the same. I don't think it's an issue on any of your examples. I'll look over them. If I have to, I'll come back and post something else. Otherwise, it's something that we will address in class on Monday.